Beckmann rearrangement is a rearrangement reaction in which ketone is converted into an amide in two steps. In this video, we'll talk about the reaction, the reagents that are used, and its mechanism. So let's begin. So this is the overall equation of Beckmann rearrangement, and you can see that a ketone has been converted into an amide. Now, as I told you earlier that it can be achieved in two steps. So in the first step, we react this ketone with hydroxylamine, and in the second step, we use acid as a catalyst. So let's see how this ketone can be converted into an amide. We'll find out this in the mechanism of the reaction, which will begin shortly. So in the first step, this ketone is reacted with hydroxylamine, and you know that this reaction produces an oxime. So what happens is that this nitrogen of the hydroxylamine attacks the carbon, shifting the pi electrons towards oxygen, forming this tetrahedral intermediate. Nitrogen loses the proton to oxygen to stabilize itself, and so this produces this molecule. The oxygen lone pair on this hydroxyl group abstracts another proton from here, which shifts these electrons between carbon and nitrogen and eliminating a molecule of water, producing an oxime, in which we have a carbon-nitrogen double bond, and the nitrogen is still attached to the OH group. This oxime is then reacted with acid in the second step. So if you add acid to the solution, the oxygen of the OH group in oxime is protonated, which can then easily leave in the form of a molecule of water. So this loses water in this manner, and as you can see that this nitrogen is becoming electron deficient. So one of the R groups will migrate towards this electron deficient nitrogen, forming another intermediate. So let's see what we have as a result is that R2 attached to the carbon, which is then double bonded to nitrogen, and this nitrogen is now attached to R1, and as you can see that we have a positive charge on this carbon atom, which can of course resonate between carbon and nitrogen because of the involvement of the lone pairs on nitrogen. This is then treated with water, which of course is present already in the solution, and this water molecule attacks the carbon atom, forming another intermediate like this. This oxygen then loses a proton to form this molecule. And this species then tautomerizes to give an amide. So this is the final product of the reaction, and you can see that we finally have an amide produced from the starting material ketone in two steps. And if you just compare the structures of the starting material, that is the ketone and the amide, you can find out that it is the R1 that has migrated from one position to another in the reaction. And rearrangement reactions, you know, that involve the migration of one group from one atom to another within the molecule. So basically we have this R1 group migrated from this carbon and carbon, which was initially the carbon and carbon of ketone, to the nitrogen. This nitrogen has been inserted in between. So this was all about Beckmann rearrangement, in which we saw that ketones are converted into amides through the rearrangement of an alkyl group from one position to another. A very interesting feature of this Beckmann rearrangement is that at this stage where the oxime is protonated and we have the loss of a water molecule, there are two R groups, R1 and R2, but only that group migrates, which is anti-periplanar, to this OH group or the OH2 here. So the group that is on opposite side of this OH2 will migrate towards this nitrogen. Like for example, in this case, you can see that R1 is on opposite side of this OH2. R2 is on the same side of the OH2. So R2 doesn't migrate in this case, but R1 does. And you can see in the final product that R1 is not attached to the same carbon and carbon as before, but it has migrated or it has shifted from its original position. This Beckmann rearrangement can occur in cyclic ketones as well, and we will see that in an example very shortly. So if we have cyclohexanone as the starting material, the ketone, and you react it with hydroxylamine, this will produce an oxime like this. And this oxime, when treated with an acid, will convert this molecule into caprolactam. Like this. And you can sense from this reaction that going from this oxime to caprolactam, there is ring expansion. This 6-membered ring has been converted into a 7-membered ring, which means that one of the ring residues has migrated from this position and nitrogen has been inserted in the ring. So this caprolactam is very important molecule because it is the precursor of a very important polymer which we know as nylon. So nylon can be produced from this caprolactam when the ring opens at some stage, and so nylon, a very important polymer, is produced as a result. So this is all about Beckmann rearrangement. We'll see you next time with another named organic reaction. Stay tuned and thank you so much for now.